Welcome back to the deep dive. I have to be honest with you, looking at the stack of research we have for today, it feels a little bit like we're breaking into a restricted area of
It
physics.
does a bit.
We're not looking at a pop science book or, a news article. We're looking at a raw technical audit. We've got these PDFs full of equations, Python scripts for Blender simulations, and these incredibly dense blog drafts from a group called Zionod Chat.
It is definitely not light reading. It's a very specific, very technical collection.
And the question they're asking is, well, it's kind of the ultimate taboo in science right now. They are basically asking, what if Einstein's theory of special relativity isn't the final truth of the universe? What if it's actually a case of what they call narcissism of description?
I know, it sounds provocative. And I want to set the stage here immediately because, usually when people hear Einstein was wrong, they think of conspiracy theories or...
Perpetual motion machines, yeah.
Exactly. This isn't that. These sources, they're conducting a software audit of the universe. They're arguing that for the last 100 years, physics has been confusing the map, which is the data we collect with our eyes and instruments, with the territory, which is what actually physically exists.
The map versus the territory. I want to dig into that, but first we have to address the elephant in the room. To even make this argument, the sources say we have to bring back a concept that modern science basically threw in the trash can in the early 1900s.
You're talking about the medium.
The absolute electromagnetic field, the substrate, the ether.
The ether, yeah.
When I saw that word in the notes, I kind of groaned. I mean, come on. Didn't the Michelson-Morley experiment in the 1880s prove that ether doesn't exist? Didn't Einstein specifically say we don't need this? Are we really going back to Victorian physics here?
That is the standard textbook stance, yes. But here's where the sources push back, and they push back hard. They argue that Einstein didn't actually disprove the medium.
He didn't.
He just decided to ignore it.
Ignore it. That seems like a big thing to just ignore.
Well, think about the context. Einstein's whole point was that you cannot detect your motion through the medium from inside a closed system.
Right.
If you're in a windowless room moving smoothly, you can't tell if you're moving or standing still. So Einstein took a pragmatic approach. He said, if we can't observe it, let's build a physics that doesn't rely on it.
Okay, that sounds reasonable. If you can't see the ghost, don't write laws about ghosts.
Right, but these sources call that a category error. Their argument is, just because you can't feel the air you're breathing doesn't mean the air isn't there. And more importantly, just because you can't measure the wind doesn't mean the speed of sound through that wind changes. They argue that by deleting the medium, Einstein forced the math to do some really weird gymnastics bending space and time to make up for the fact that he deleted the background.
So we deleted the stage, and then we had to make the actors float to explain why they were moving.
That is a surprisingly good way to put it.
Okay, so let's humor the Zionod chat group. If we bring back the medium, this absolute background stage, how does that fix anything? Because they talk about these three worlds, and I read this part 3 times, and I think I get it, but walk me through it.
This is the foundation. To avoid the paradoxes we see in modern physics, the sources say you have to strictly distinguish between 3 layers of reality. Layer 1 is the mathematical world.
Okay, that's the whiteboard.
Exactly. Pure logic, formulas, geometry. The Lorentz transformations, the math Einstein used, live here. They are internally consistent. They work on paper. No one is saying the math is wrong as math.
Okay, math is math. What's layer 2?
Layer 2 is the physical world. This is the territory.
Right.
This is the electromagnetic medium itself and the actual events happening within it. In this world, cause and effect are absolute. Things happen where they happen, regardless of who is watching.
Okay, so a tree falls in the forest, it physically falls. Got it. And layer 3?
The observational world. This is the map. This is the delayed, distorted image you receive because light takes time to travel to your eyes. The critique here is that relativity treats this observational world, the distorted map, as if it were the physical world.
Wait, hold on. Give me a concrete example. Because if I see a car crash, I see the car crash. Are you saying what I see isn't real?
I'm saying what you see is old news. Imagine you're watching a live broadcast of a football game, but there's a 7-second delay.
Okay.
On the field, the physical world, the quarterback has already thrown the ball. But on your screen, the observational world, he's still holding it.
I see.
Now, imagine you didn't know about the delay. You'd think the ball's in his hand right now. You would define reality based on that delayed image.
Okay, I follow. I'm living in the past.
Now, imagine you're moving and the camera's moving. The delay shifts. Sometimes it's 7 seconds, sometimes it's 10. If you tried to build laws of physics based only on what you see on that screen, without accounting for the variable delay, you'd come up with some crazy rules.
You would.
You'd say, wow, when the camera moves left, time slows down for the quarterback.
But actually, the signal just took longer to get to me.
Precisely. And this brings us to that character
Rah.
the sources keep obsessing over.
The boss observer.
The boss observer. Or upper management.
I love the idea of the universe having upper management. Who is the boss?
The boss is a theoretical observer who is sitting perfectly still relative to the medium. Coordinates x equals 0, z equals 100. Just floating there, watching the whole system.
Right.
But here is the key. The boss doesn't just believe their eyes. The boss calculates the ground truth.
Ground truth. That's a term from data science, right?
It is. The boss knows that light takes time to travel. So if the boss sees a star explode and knows that star is 1,000,000 light years away, the boss logs the event as having happened 1,000,000 years ago. The boss corrects for the lag.
Whereas Einstein's observer, let's call him the employee, he just says, I see it now, so it's happening now.
And that is what the sources call the narcissism of description. It's the belief that the universe shrinks or slows down just because your view of it is delayed or distorted.
It's like thinking the room is actually spinning just because you're dizzy.
Exactly.
Yeah, it's a heavy philosophical charge, calling general relativity narcissism. But they don't just throw insults, they have this simulation, the banana face.
Yes.
I really want to get into this because they actually wrote Python code for Blender to prove this point. Tell me about the banana face.
It's a thought experiment to demonstrate this distinction between the object, the territory, and the image, the map.
Yeah.
Imagine you are driving a car on a road. Next to you, there is a train track. A train is moving on that track.
Okay, how fast are we going?
Fast, relativistic speeds. Let's say the train and the car are both moving at 50% the speed of light.
Safety regulations have clearly gone out the window.
Clearly. Now imagine there's a mirror attached to the side of the train. You, the driver, want to take a selfie using that moving mirror.
So I'm in a moving car, looking at a moving mirror, trying to take a photo of my own face.
Correct. Now, think about the light. You have light reflecting off your nose and light reflecting off your ear. They're in different physical locations on your face.
Right. My nose is in front of my ear.
And you are moving. The mirror is moving. So when a photon leaves your nose, it has to travel to where the mirror will be.
Right, right.
It's like a quarterback throwing a football to a running receiver. You don't throw to where the receiver is, you throw to where he's going.
Leading the target.
This is called deflection shooting.
Okay, got it.
But here's the catch. The light from your ear has to travel a slightly different path, a different distance, to hit that moving mirror and bounce back to your camera lens.
Because my ear is further back.
Further back and at a different angle. So for the light from your nose and the light from your ear to arrive at your camera at the exact same moment to create a photo,
Yeah.
they had to leave your face at different times.
Oh, I see. My camera clicks once. It captures all the photons that arrive right then. But the photon from my nose might be a younger photon, and the photon from my ear might be an older photon.
Exactly. You are assembling an image out of data points from different times in history. And when you stitch that together, the geometry gets weird. In the simulation, your face isn't round anymore. It looks curved.
A banana face.
It looks like a banana or a boomerang.
Okay, but here is the million-dollar difference, right? Einstein's relativity Lorentz contraction would interpret this by saying,
It would say, in this reference frame, your face is squished. The space itself is contracted. Your skull is physically deformed relative to the observer.
that's the standard interpretation, length contraction. My face is physically a banana in that frame.
But the Zionad chat sources say, no, your face is still round.
Okay.
The physical world hasn't changed. Your skull is fine. You were just looking at a funhouse mirror effect caused by the signal lag and the speed of light.
So the banana face is just an artifact of observation.
And it's not a new law of physics.
That is actually a huge distinction. One says reality bends, the other says the image bends.
And they argue that believing your face actually became a banana is the narcissism. It's confusing the data gathering process with the object itself.
I can see why they call it a software audit. They're debugging the code of observation. But speaking of code, I want to look at the math they used for this Train King example, because this is where I got a little lost in the numbers.
The Train King is where they try to prove this mathematically, using what they call deviation shooting. It can get dense, but let's visualize it.
Okay, paint the picture.
Imagine a train that is 20 units long. Sitting exactly in the middle, let's say it's seat number 10, is the king.
Good to be the king.
Now, the king wants a message from the rear of the train. He wants it to arrive in his hands exactly at time equals 10.
Okay, message arrives at 10 equals 10.
The question is, when did that message have to leave the rear of the train?
Well, if the train is stopped, it's easy. If the rear is 10 units away and light travels at speed 1, it takes 10 seconds. So it left at equals 0.
Right. But the train is moving. Let's say it's moving forward through the medium. The king is moving away from the spot where the message started.
Oh, right. It's a chase scene. The light signal leaves the back, but the king is running away from it?
Exactly. The light has to run a marathon just to catch up to the middle of the train. It has to cover the length of the train plus the distance the train moved while the light was in transit.
So it must have left way earlier than d equals 0.
Much earlier. The source calculates that for the light to arrive at t equals 10, it must have departed the rear of the train at approximately t equals minus 5.26.
Wow.
It took over 15 seconds to make that trip.
Okay, so the lag from the back of the train is huge. What about the front?
The front is the opposite. The king is running towards the signal coming from the front. He's ramming into the light, so that trip is super short.
So if I'm the king, I'm getting messages from the front almost instantly, and messages from the back are from ancient history.
Yes, and this leads to the most critical technical concept in these documents, Protocol 01, the event anchor.
Protocol 01, it sounds like a sci-fi directive. What is it?
It's the mechanism that explains why the light takes so long. Standard physics often assumes, subconsciously, that light kind of rides the train. But Protocol 01 says, no.
So if I flash a light on the train, the light doesn't stick to the train.
Think of it this way. Imagine you are on a boat in the ocean. You drop a heavy anchor into the water.
Okay.
That anchor is the event. The moment the flash happens, the coordinate of that event is dropped into the medium. Let's say at coordinate x equals minus 10.5.
Okay, anchor dropped in the water.
Now the boat keeps moving. The flashlight that made the flash keeps moving. But the center of the light wave, the ripple, stays anchored at that spot in the water. The light ripples out from that fixed point in the ocean, not from the moving boat.
That changes everything. So the light doesn't have the momentum of the train.
Right.
It's purely a wave in the stationary medium.
Exactly. The source emphasizes this. Light is not left behind, but the event anchor is. The train moves on, but the history of that flash is locked to that specific coordinate in the medium. This is what allows the boss observer to reconstruct the truth.
Right.
If you know where the anchor was dropped, and you know the speed of light, you can calculate exactly what happened and when, stripping away the illusion of the moving train.
It feels like they are trying to rebuild physics from the ground up, pixel by pixel.
That is literally what they are proposing, and they use a really powerful analogy to explain why the old way using inertial frames is flawed. They compare an inertial frame to a modern nation.
A nation? That seems abstract.
Think about it.
Yeah.
What is national income? It's an average. It's a single number that represents millions of people. If I tell you the average national income is $50,000, does that tell me anything about your specific bank account?
Not really. I could be broke or I could be a billionaire. The average hides the details.
Exactly. The source argues that an inertial frame-like, the coordinate system of the train, is like that nation. It forces all the individual points to agree on a single time. It smears the data.
And the citizen is the individual event.
Yes. The citizen is the individual pixel of reality. The source argues that standard physics destroys physics by averaging everything out. By forcing every point on the train to conform to one train time, you wipe out the individual travel history of each light ray.
You ignore the details.
You ignore the fact that the light from the rear citizen took 15 seconds to reach the king, while light from the front citizen took only 5 seconds.
Because we just want to say the train is at time t. We're oversimplifying.
We are smoothing out the data until the truth disappears. Relativity covers up the individual struggles of the light rays with math to make it all look simultaneous inside the frame. But the Zionat chat model says, stop looking at the nation. Look at the point cloud.
The point cloud model. I see this term used in 3D scanning a lot.
It's the same idea. Instead of defining a smooth surface, you define a cloud of millions of individual dots. They argue reality isn't a bent sheet of rubber. It is a 4-dimensional point cloud in the medium. We need to track every single pixel. Where was it emitted? When? How long did the signal take to get here?
That sounds incredibly computationally expensive.
It is. That's why we couldn't do it in 1905. Einstein had a chalkboard. He had to use averages and smooth geometry.
Okay.
But today, we have GPUs, we have Python. We can actually simulate the point cloud of the universe.
So the image we see with our eyes,
Yeah.
if we use this point cloud model, what is it?
It's a mosaic, a patchwork of delayed messages. Some pixels in your vision are from a nanosecond ago, some are from a second ago, stitched together by your brain into a coherent image. The banana face is just what happens when that stitching process gets extreme because of high speeds.
This is really shifting my perspective. We're moving from a world where space and time act like magic putty bending and stretching to a world where space and time are rigid, cold, and absolute, but our information about them is elastic and delayed.
That is the core takeaway. The implications are massive. If this model holds, it suggests that things like time dilation and length contraction aren't physical realities.
They're illusions.
They are illusions. They are artifacts of trying to draw a map based on really, really slow mail delivery.
It's like we've been trying to do geometry using a funhouse mirror, and we created complex laws to explain why the lines are curved instead of just realizing.
It's the mirror.
It's the mirror.
Precisely. And this is where we have to be humble. This doesn't mean the math of relativity isn't useful. It works for GPS, it works for predictions. But is it the territory? Or is it just a really good map?
The source material ends with a final provocative thought that I think we need to leave the listener with. It's about quantum mechanics.
Oh, this is the part that gave me chills, they ask. If we stop looking at the nation, the frame, and start looking at the citizen, the individual data point, do the paradoxes of the quantum world disappear?
They're talking about spooky action at a distance, entanglement.
Right.
All those things that make no sense in our current model. They ask, are we just looking at a banana face on a quantum scale and calling it a new law of physics? If we rigorously applied this point cloud model, specifically accounting for the lag of every single interaction in the medium, does the weirdness of the quantum world simply dissolve into geometry?
That is a thought that's going to keep me up at night. Are we complicating the universe because we refuse to admit our view is just slow?
It is the ultimate question of humility in science. Are we describing the universe, or are we describing our own limitations? The Zion chat logs suggest it's time we stop being narcissists about our observations and start respecting the territory.
Incredible stuff. It really makes you want to look at a star or even just a mirror and wonder what you're actually seeing. A massive thank you to the Zion chat group for these mind-bending sources. It's not every day we get to audit the source code of reality. And thank you, listening, for taking this deep dive with us.
Keep questioning the map.
See you next time.